Hi everyone, welcome back. I'm laughing because I'm trying to avoid the temptation of going totally crazy on these questions. You can really go crazy. So here's some ones I thought up after the other video. I thought there's a bit of a twist. They'll become a little bit more fiddly, I could say revolting, but the rules apply to it. We've got a 4, we've got an 8, we've got a 32. Most people will be comfortable that that's 2 squared, 2 cubed, and 2 to the 5. If you haven't memorised 2, 4, 8, 16, 32, it's a good thing to go home and memorise that. So I can write that as 2 to the power of 2 to another power of x plus 1, so I put a bracket around it and put an x plus 1. I can write that as 2 to the 3, 2 cubed. I can write that one. Now here's where it gets a bit annoying. 32 is 2 to the 5, and then it's got a square root. So that square root is another power of a half. So it's actually 2 to the 5 raised to the power of a half. Let's have a look what this does to the question. So this one becomes 2 to the 2x plus 2 if I expanded that bracket there. That's 2 cubed. Now this one is 1 on 2 when you go 5 times a half. So what's 5 times a half? Or you could say what's a half of 5, and you could go 2 and a half. Let's have a look what's happened here. Now I can, when you're multiplying and you've got the same base, I can add the powers. So that's a 2x, a 2 plus 3 is a 5, and this is when it goes from the denominator to the numerator. What do? This was a positive, it becomes a negative, so I've got a negative 2 and a half. Bit of fractions involved. If I take 5 from this side, I take 5. Most of you see that in your head. And I got 2x is minus 7 and a half. If I divide this side by 2, I divide that side by 2. And how much do people have trouble with fractions? I've got x, so that's minus. This is 2 7s are 14. Plus 1 is 15. 15 on 2. Now how do I get rid of a 2? I write it as a 2 on 1. Then I invert and multiply. So I go turn the denominator upside down, which is a half, and I turn into multiply. And every time I think people are okay with fractions, when I look at the waste reports, you see how much they keep saying Year 12 students in Australia who are good at their maths have trouble with times tables, with fractions. So now I just say to people all the time, multiply the tops and multiply the bottoms. 15 ones are 15, 2 2s are 4 with a negative, and the answer is minus 3 3/4. So if you wanted to write minus 3 3/4, you can, but you don't have to. That's correct, and 4 marks. These are 9, 27, 3 and 81. So here you go, it's using all of them. 3, 9, 27 and 81. So we're using all bases of 3. So we're talking about the powers of the 3. So this one is 3 squared, and I've put these little blue brackets around it to say that really does have a bracket around it when it's written as a power. So I've got 3 squared with an x plus 1. This one is 3 cubed. This is 3 to the power of 1. And this one is 3, 9, 27, 81. So that's 3 to the power of 4. So I've got 1 on 3 to the power of 4. I've got some yucky stuff to do, but it's not too bad. So now I've got 3 to the power of 2x plus 2. That's that one there. If I move this 3 from the bottom to the top, it becomes multiplied by 3 to the power of minus 3. So the 3 on the bottom becomes a minus on the top. And then I've got divided by 3 to the 1. And that 3 to the 4 becomes 3 to the power of minus 4. Now here's my equation. Watch me write it all out. That's a 2x plus 2. And I've minus the 3. When you're dividing, I've minus the 1. So I could have just said this was minus 3. This one here is minusing that 3. And that's minusing another 1, bit confusing, and that's a minus 4. So I can just go ahead and go 2x is 2 take 4 is minus 2, and I can go add 2 to both sides, and I've got 2x is minus 2, and I make up some weirdo question, and it turns out the answer is minus 1, which is rather nice when I write up a question like that. Probably gone far enough, could go further, but maybe your teachers will come up with something and you apply the rules and just stick to it. Remember, you're always looking at a common base, and once they've all written with a common base, and by the way, interesting part is because these are times and divide, I can apply the index laws to them. But I need to go a step further and put another video on. But if you're enjoying them where they are at the moment, please spread the word. Thank you.